So 2.5, 24?
3.5.
3.5. 24? Okay. So this one says y less than negative 3x plus 1. So this one will be kind of gross if you graph equations and lines by finding intercepts. The intercepts can very often be ugly. So if instead I use the slope in the y-intercept, it might be a little bit better, right? I'm not sure where this, and this is the problem you're talking about, right? Mm-hmm. Okay. So in this case, what's the slope of this line? I like it, negative 3 over 1. So it's the coefficient of the x. And what's the y-intercept? I like it, thank you. 0, 1, cool. So the first step on these problems, they are inequalities. And remember what I said about inequalities. Inequalities always allows for more answers than normal. So inequalities like x less than 3, we shaded one side of the number line. Inequalities like this with two variables, I'm going to shade half of the entire plane, the xy plane, the whole coordinate system. I'm going to shade half of it. So where do I start with my line?
0, 1.
Yep, 0, 1. And the slope tells me to go down 1, 2, 3 over 1. I like it. What kind of line am I going to put through there?
Solid. Dotted.
Yeah. So remember, dotted is just like the open circle. I don't want to include the line. So the best way I have to show that is to make a dotted line. What that really means is if I put any point in this line into this inequality, it won't work. So what point is this? What point is this? 1, negative 2. If you plug in 1, negative 2, let's try it real quick. If you plug in negative 2 for y and 1, you could do it, Jeff.
Are you just trying that out, you said?
I'm just trying it out. You guys cool with that? I plugged in negative 2 for y and 1 for x. What do I get? I get negative 2 less than, what's negative 3 plus 1? Negative 2. Is that true? Is negative 2 less than negative 2? No. So you get the idea. A dashed line is just like an open circle. It says don't include these points, they don't work. If I make a solid line, that means yes, these points work. So how do you tell? Well, if it's got a line, you make a solid line. If it don't, you don't. This is strictly less than. It can't be equal to, so you make it dotted. How's that so far? So if you're able to graph a line from the slope and the y-intercept, number 1. Number 2, understand it's an inequality, so it's got to have some kind of open circle, closed circle idea. And that's how it relates to lines. Dotted is like open circle. Yeah?
2 questions. So pretty much you're using the y-intercept as a point.
Yes.
Okay. And the next question is, what if it's not in y and then
You put it there.
okay.
Or, you really could find the x and y-intercept if you want to. It doesn't say use the slope of the y-intercept to graph this, but what I really want us to understand is that's the quickest way to do it. But if you have other ways you like better, I almost don't care, as long as that line gets down there and then you're able to figure out which way to shape. But I really do want you guys to get used to doing it. That's the quickest way to do it. It's just straight from the mx plus b. Yeah?
What I did is I plugged in the point 0, 0.
We're not there yet. Now I can do it. That's the next step.
Okay.
So we were talking about getting here. So to get here, you have to know slope and y-intercept. There's some way to graph a line. And there's a dashed, dotted or solid. Now how do you tell which side to shade? That's where you plug in the test point.
Oh. Okay.
And I always try 0, 0 if I can. The only time I can't is if the line goes through it, because then that's on the line. How does it tell me which side to go on? That's a dude sitting on the fence. Which side you on? I'm up here. That's exactly how he would talk. So when I plug 0, 0 in, so here's the equation, here's the inequality. When I plug 0 in, 0, 0, what's this?
0.
Good. 0 less than 0 plus 1 is 0 less than 1?
True.
Yes. So which way do I shape?
On the side with 0, 0.
On the side is 0, 0. Not over there. That worked, so all these must work. It's an all or nothing situation here, right? So that means I shade this way. Which means what about that point?
It works.
It works. That whatever that point is, it would work in this inequality. And of course that point would not work. Whatever that point is, it would not work. Cool. How are we doing?
How do you want us to answer the 1 through 6 on 3.5?
Honestly. No, I don't know. It says use one of those symbols. So for example, number 1 says HIV/AIDS has killed more than 25 million. So which symbol is related to that? Greater than. This way.
Okay, so
Greater than, yeah.
we give them
So just translate those bold statements into just the symbols.
like,
So more than is greater than.
oh, like,
So that's the only thing I want to see in the answer is that kind of thing. They go on, they have another bold thing, they have another more than, so that's another greater than. So number 1 would look like this. 1 would look like that.
oh, really? Oh.
There's 2 bold statements. I need them translated each into a symbol.
Okay. I think I'm thinking too much. I'm like, don't you need a
Yes.
variable or something?
What would at most be? At most, like you can be at most 12 to eat off the kids menu at Denny's.
That's true. Didn't I work there?
It's true.
Yeah.
Oh, I know. You can be traveling cross country. It's 3 in the morning. Denny's is the place to go. You could be at most 12. Can you be 13?
No.
No, you can't. So at most 12, which symbol would that be?
If you're jumping.
I would have to be how related to 12 to eat off the kids menu?
Less than or equal to.
Less than or equal to. So at most
Less
is
than.
that, which is kind of backwards from what we first think of when we say at most. But at most means it must be below something. You must be at least this tall to ride the ride means from here up. So at least would be greater than or equal to. You with me? So that's what they're really checking here. Do you know how to translate from English to math with inequalities? And if you don't, they discuss it in the section. So you should read the section.
Yeah.
Or come see me after.
I'm coming over it now.
Okay. Any other questions? Yeah.
Can you do number 21 on page 254?
Yeah, if I remember correctly, 21. Yes, 21 is an evil one for this. So let's do that one together. And there are certain, I don't necessarily assign them on purpose, but there are certain problems that if I don't hear a question about them, I get worried that nobody's doing the homework, right? So you just made me feel a little better. So number 21 says solve by graphing.
Which section? I'm sorry.
4-1.
Yeah, 4-1.
This is still the problem, right?
What's that?
This is just the problem.
Yep. So that's the problem. That's what they give you. They want you to solve this system by graphing. So thinking ahead, how many lines did I just write down there? 2. There's a line there, there's a line there. If I graph them, the answer will be apparent where they do what?
Intersect.
Where they meet. Like, so they could meet once, they could meet nowhere, and that would be no answer. Or they can meet everywhere, and that would be all points on the line. Because the answer to a system of equations is a point. So don't say all real numbers, that doesn't make a damn bit of sense. It's got to be points. So before I go to graph these, what should I do? Solve for y. So, all right, let me I always want to do this a little bit quicker. Here I could subtract 3x. Cool. And then what do? Divide by -2. So it makes it y equals 3/2 x plus 3/2. That's the evil part.
What is it? Is it 3/2?
Yes. Cool.
So wait, do you leave it like that then?
Say again?
You leave it like that then?
Yes, because what can I see now? What form is this in? I see the slope is, you almost can't go wrong. 3/2. And the y-intercept is 0, 3/2. Okay. Equation 2. How do I solve that for y?
Add 3x.
Add 3x. Cool.
And then divide by a negative.
And then divide by negative. So you get y equals -3x
Plus 6.
plus 6/11.
Cool.
What's the slope here?
Negative
-3/1. And what's the y-intercept?
0, 6.
0.611. Cool. So now you can graph both of them. This one, can you see why this is ugly? Number one, the y-intercept is a fractional part. It's not really an ugly fraction. It's 1.5. I can find that. But counting the slope from there is what's going to be ugly. I don't know if you guys can see that yet, but let's see what happens. Okay. All right. So let's first graph this guy. Seems to be the nicer one, right? Where do I start for the graph of this guy? 0.6. And the slope tells me to go down 3. 1, 2, 3 over 1. 1, 2, 3 over 1. Sorry. 1, 2, 3 over 1. Okay. And there's my line. Oh crap. Make that big. Any one of those giant board rulers, otherwise known as meter sticks. So that's equation number 2, right? Put a little 2 on there so I keep myself straight. Now, how do I start graphing the first equation? Where do I start there? What's 3/2? 1.5. So there's the y-intercept. Now let me see. Now this is why I'm okay with doing this together with you. You will not have to do this kind of thing in this class again, but I want to see if you guys understand this. If the slope was up 1 over 2, you with me? Now let's watch. Nothing to do with this yet. If the slope was up 1 over 2, could I do up 2 over 4? Would that still get me back to the line?
Yeah.
Yes, of course. Any multiple of those steps would help, right? That would just be like a couple of up 1 over 2, up 1 over 2. So couldn't I also do up 1/2 over 1? If I go up 1 over 2, what's half of each? Up 1/2 over 1. That would work also. Any multiple. Let me do a little side problem here. Just watch. So if I had an equation like 2x minus 1. Here we go. Stay with me.
What do you mean? It says if the system is inconsistent or the equations are dependent. What does that mean?
Remember I said I wasn't too worried about the words? Consistent means one answer, inconsistent no answers, dependent means they sit right on top of each other.
Oh, okay.
But I don't really care too much about if you know the name of it.
Okay.
I'm really more concerned with, can you solve it to an answer? Good.
Okay.
Don't tell me this is the name. I don't really care. So here, I'd start here, wouldn't I? And the slope tells me go up 2 over 1. But I could go up 1, 2, 3, 4 over 2. Of course I could, because that's like going up 2 over 1, up 2 over 1 twice. Ooh, big deal. But that should mean I should be able to go up 1 over half. And that still is on the line of course. If I want to get really silly, I could go up half over a fourth. I'm still on the line. Do you see what I'm saying? You don't have to do this very often, but this is the way to get out of the trap of a fractional y-intercept. Stay with me now. Because this kind of sucks that I am sitting at a halfway point. So here's what I could do. What's the slope of this second equation? First equation? The slope is 3 over 2, right? So look what that really means. Could I say that means... You guys are cool. Isn't 3 over 2 over 1, isn't that still 3 over 2? 3 over 2 divided by 1? So I could go up 1.5 over 1. That's what that says. Can anybody see what good that would do for me? Would I still be at a halfway point? Would I still be at a halfway point if I go up 1.5 over 1? I don't know if you guys see that. So if the slope tells me to go, now you guys are cool with me over there. Let me make you cool again. If the slope tells me to go up 1, 2, 3 over 2, it tells me to do that, doesn't it?
Yeah.
Shouldn't I also be able to go up half of each? If it says go up 3 over 2, shouldn't I be able to go up 1.5 over 1? It's a multiple. I should still be able to do that. You guys are all with me there. It's the same idea over here. The slope says go up 3 over 2. I'm like, screw you, slope. I want to go up 1.5 over 1. I'm still on the same line. And what's the answer? What's the answer? Where do they meet? 1, 3. You would never see that if you didn't realize you can take those half steps. So you'll never have to do that kind of problem again in here. I wish they wouldn't have done that in that section. That's a little bit too ugly for that section. So there's a gimme right there. You guys can copy all that down, throw it in your homework. I'm cool with it. But I'm desperately hoping you kind of get the feel for that. You could do any multiple of steps. 1, 2 should be 2, 4 should be good. But you should be able to go the other way. 1, 2, 1/2, 1 should be good. So 3, 2, 1.5, 1. That should be good. It's the same ratio, isn't it? Okay, maybe. Yeah.
That second line, that's on the y-intercept, that's in the middle, that's the 3 over 2?
Yes, what's 3 over 2? As a mixed number. What's 3 divided by 2? 1.5. So 1.5.
So to get that, fractions are not my friend. So you would see how many times 3 goes into 2.
2 goes into 3.
2 goes into 3, and then leaves 1 remaining.
Yes.
So it'd be 1 over 1.
1.5.
Or 1/2.
Yeah. So 2 into 3. 1.5. Remainder. Cool.
Yeah, sorry.
Yeah.
Okay, but you write it here as 3 over 2 and over 1.
Yes.
So what mean over 1? You mean half?
No.
Understand.
1. So what's it say to do now? Go up 3/2. Go over 1. That's what I did. I went up 1.5 over 1. Bam.
So why you put over 1?
Because I wanted to. What's slope? Slope is rise over run. With me? So we normally, 3 over 2, we think, well, there's already a rise over a run.
Yeah.
But can't I put that whole thing over 1? Isn't that mathematically the same thing? I don't want to spend too much more time on this because this is more than we really need to do. But I would like you to kind of get the idea here. I can put any damn thing I want to over 1. Can't I?
Yeah, you can.
Beautiful. Now, just like mathematically, math doesn't care if I have the negative on the top or the bottom. But remember how we were talking that would mean go up and over or down and back? So graphically it cares where the negative is. Which way am I going to go? putting something over 1, math goes, ooh, way to go. But what does graphing go? Graphing goes, oh shit, all right. So you only want to go over 1, but you want to go up 1.5. I mean, to slope, it changes what you want to do, how far you want to go.
So, okay, if I have like 7/3, I can't put, I go with 7/3, I put it in the y and
Over 1.
Over 1 only.
You can always do that, always, if it makes sense. But you can do it even if it doesn't make sense. You're allowed to do it. Why did I do it here?
You don't have to.
I did it here so that it would actually match up. Because the other equation was getting to all these whole numbers, weren't they? The other equation was giving me all these whole numbers. Where did I start off? A half a number. Shit. I needed to get away from that half a number, so I took a half a step. If I take 1.5, I'm at 3 now, aren't I? And then over 1, now I've got a nice whole number. And the bonus is I ended up right on top of another point. So I already know the answer. I see where they meet. So I've talked about that problem way too much. So that's it for that problem. Right, so that goes a little bit beyond what we need to know. So if you didn't get a damn thing out of the whole discussion, let it go. It's okay.
Let it go.
Let it go. Let's see. So let's get into some new stuff. So you can already see, obviously, that there are problems that I would rather do a different way than graphing. That's a really good example of it. And in fact, I'll come back and do that problem again algebraically and show you how quick it is. Before I did this, I very quickly in my head did the algebra just to make sure I knew where it was going to end up so I would know how to approach teaching it. You with me? So once we learn the algebra, that problem is crazy easy. So to solve systems of equations.
So this is still 4-1?
4-2. We can do it graphically. That's section 4-1. Or we can do it algebraically. So I know how to spell algebraic. Yeah. And there's 2 main types of ways to do it algebraically. There's one that I call the elimination method, and this book does too. Yay! Sometimes me and the book don't agree. There's the elimination method, which is section 4.3 actually, and there's the substitution method. Okay, so that's a little overview of the first 3 sections of chapter 4. They all deal with the same thing. 4.1, 4.2, 4.3. They're all doing the same thing. They're trying to solve systems of equations. But this one definitely doesn't work well for a lot of things. Because like I was saying the other day, if the answer is 1.89, 2.7, I am most likely not going to get that from a graph. I am not that precise on my graphs. And not just because I'm messy. Most of us are not that precise. So how do I do these things? Let me do it in the reverse order I got them there. Same order as the book. Let's look at substitution first. No, of course it doesn't. Make it 9, 11. Okay, good. So, both of the algebraic ways to solve systems of equations address the same problem. Systems of equations, they all have the same problem. Each one of these stupid things has 2 variables. How the hell do I solve? I can get x by itself, but then what's on the other side? Y with some other crap. Do I know what x is yet? No shit. So the problem that they both address is there's too many freaking variables in each one of these, right? So what I do is I use one piece of information for substitution. in the other one. So this first one, I know that 3x minus 4y is 11. So I basically don't know much, right? Because how many answers are there to this? A lot. An infinite number. But on the second one, I know that x is y plus 3. So what's a smarter way to write the first one now?
Would you do 3 and then times x?
Yeah, 3 times x. But like you said,
y plus 3.
x is y plus 3. So I'm just going to put that there. And that's the incredibly creative math people. They said, let's call this substitution. Because I'm substituting in place of x, I'm putting what it is. Substitute that into there. Don't substitute something back into itself. That's what's called circular logic. You'll end up with 2 equals 2, and you'll say, oh, it's a bunch of infinite number. No. You have to use both pieces of information. You with me? Plug one thing into the other thing. So help me out. Keep going here. How would I write the rest of this?
Minus 4y.
Beautiful. Minus 4y. So this is here. This is here. This is here.
Slow down.
I'm right here. Yes?
Substitution only works if you have like a nice little x equals something.
It'll work all the time. It is nice to use when you have something without a coefficient. Because otherwise, if you solve for a letter, you might get a bunch of fractions, right? So this was obviously nice, and of course this is our first one, so I want to make it really nice. Because I could actually use y if I wanted to, solve for y. Both of these have only a 1 coefficient, so I'm not going to get any fractions when I try to solve for a letter. It's already solved.
Will they ever give you y to substitute?
Of course, yeah, definitely.
Okay.
In this case, it was just already set up for x.
Okay.
I could have said y equals x minus 3.
And on the test, are you going to tell us, like, use substitution?
Oh, yeah. Because if there's enough room on the test, I put solve using any method you want, if I have enough space to include another problem. But I have to have one to make sure you can do substitution, and I have to have one to make sure you can do elimination.
Okay.
Otherwise, somebody might do the same method all the time because they don't know the other method at all.
Okay.
Yeah. Before I forget, I do have the practice test, so I know there's a few people already left, so you probably want to get that before you leave. Now what do I do? Now, what do you notice? Here there were 2 variables. I can't solve. Here there's only 1 variable. Cool.
Could you distribute it?
Yeah, distribute. Now I'm back into chapter 2.
Like terms.
Good.
So
So
it's
you get
-y.
negative y plus 9 is 11.
Minus 9.
So y equals 2.
Negative y equals 2.
And then if you do positive, like
Y equals negative 2. Now, do I go to the next problem now? I'm done. Yay.
Yay.
No.
Am I?
No.
Now you plug in y.
You have to put 2 back in y.
Exactly. Because what's your answer to a system of equations? I don't care what method you use to solve it, the answer must be a point.
Oh.
So I've only got half of the point. I got to get the other half. So now I know that y is negative 2. I call it dominoes. It kind of falls back. Just put the negative 2 in.
To that equation?
Either one, but isn't this the better one?
The easier one.
Either one is a good check, because either one you put it in, it better come out the same, because that's where they both meet. It's got to be the same.
Are we checking now? Is that what?
No, we're not checking. We haven't got the answer yet.
Oh, okay.
So x equals y plus 3. Y is negative 2. So x is 1. So if you leave it there, I'll be okay, but what should your answer be? I like it. The answer is 1, negative 2. And that is the point where what would happen?
These
So they would meet.
The 2 lines would meet if I graphed them. I like it.
Okay.
Everybody with me so far?
Yeah.
So don't just stop when you get a letter, x equals 7, yay. No, plug it back in, get what y is.
But that negative 2 will work if you fill it in either equation.
Either equation's got to work. Let's try it real quick. If you plug in a negative 2 here, here's a check. 3x minus 4 times negative 2. 3x plus 8 is 11. Subtract the 8, you get 3. X is 1. Sweet.
Okay.
And think about it. If that's where they both meet, that same point has to work in both. It doesn't matter which line you use then. It's the same point. How are we doing so far? Of course, the sucky thing about any check is if you make a mistake in the check itself, you'll think you're wrong when you're really right. So be careful about your math in the check. Yeah.
Okay, I have a quick, simple question. But if you're given a point and you're trying to see if the point works in the system, if it works for one and doesn't work for the other, it's neither?
If it works in one and it doesn't work in the other, that's not a solution. A solution to a system of equations has to work in both. Because how many things work in one? An infinite number. So if you find a point that works on one, ooh, there's an infinite number of them, right? Find the one that works in both is the real thing to get. Okay, so what do you do about this? Still by substitution.
Is this another example?
Another example. Let's see. Of course, I always got to make these actually work. That would be nice, Jeff. Oh well, too bad. So I want you to solve this using substitution. The first one was crazy easy. Why?
Because of the X.
I already had it. X equals something. I already had it there. I don't have it, but big deal. What do you think I should solve for?
Solve for what?
Why?
Just by itself.
Good, because its coefficient is 1, basically, right? If I solve for any of these other ones, I'm going to get a bunch of fractions, which you should be able to do, but to be smart, you don't do that. You don't bring fractions in if you don't have to. So what do you get when you solve number 1 for a y? Plus your
X, 4x minus 4.
add y, subtract 2, is that cool? You get y equals 4x minus 2. If you add y, subtract 2, bam. Y equals 4x minus 2, is that all right? You guys can do that. But what can I do now? Who do I rewrite? Which one?
Second one.
This one. Good. The second one I can write as 5x plus 3 times. Beautiful, because that's what y is.
Wait, what did you do? Oh, you.
I'm not done yet. 5x plus 3 times 4x minus 2.
That's what y is.
That's what y is. Good. So I'm using one piece of information to help me out with the other one.
Okay.
So now again, I'm on the level where I only have one variable. 5x plus 12x minus 6 equals 11.
Like terms.
Good.
And add 6.
17x plus 6 equals 17.
X equals what?
X equals 1, right? Divide by the 17. And?
I have to plug x in.
Good. And the cool thing about substitution method, you're always going to have an equation that's already solved for the other variable. Do you see that?
So where'd you plug in for the X? Where'd the 1 go?
Haven't done it yet.
Oh, sorry. Okay.
So the cool thing, again, is I have an equation. You can plug it into either one, but to be smart, I'm going to plug it into this one because it's already solved for y.
Oh, okay. So
So plug a 1 in. Y equals 4 times 1 minus 2. Y equals 2. So what's my answer?
1, 2.
1, 2. Okay, cool. So that's not too bad, is it?
So now,
I will warn you, I think there is one problem in there where they say do it by substitution, so you have to use fractions to do it.
Ew.
You can do it.
No.
Yes, you can. You better be able to do it. Let me say it like that.
huh.
So if it doesn't work, is it undefined or not a real solution?
Yeah, you can still get the same exact answers here. If I did this and I got 0 equals 0, what do you think that means?
Not a real solution.
If I get 0 equals 1, that's no solution. That would be parallel lines. You with me? Because that's never true, right? If I get 0 equals 0, that should be an infinite number of answers, remember?
Okay.
So algebraically, there's got to be this situation. Well, we did this situation. We got 1, 2. It met at one point. There's got to be this situation. That would be 0 equals 1, no answer. And there's got to be this situation where there's an infinite number of answers, and that would be 0 equals 0 or 3 equals 3, something that's true. And we've seen those kind of equations before. But now it's the same thing in systems of equations. Same kind of stuff can happen. So here, you guys try this one.
My substitution, yeah.
Substitution, yeah. It's the only thing I've shown so
I
far.
didn't get X, exactly.
Shoot, now you maybe forgot. Okay, that should work. No, it's a no.
Yeah, or in the first one.
That's a Y.
Right, okay.
Yeah. Actually took one semester science. I was back on the skills. But one of the there's sentences in the book was the baby swims in the morning. That was the actual sentence in the book, so that's why I remember it. So
Well, you remember the science.
I know. That was so weird. I'm like, what baby? So make sure everybody's on the right track. Which variable will you solve for?
Number one.
And number one, you'll solve for y because it's not going to make any fractions, right?
That's what I meant.
Sweet. It's the next, that's elimination. Different method, but yeah, that's reality.
So for the top one, I ended up getting y equals negative 2x plus 11. Right?
I got y equals x minus 11.
All right, guys. So if you solve number one, well, you can say 11 minus 2x. I'm stuck in the mode of mx plus b. Really don't need. So if you made 11 minus 2x, you're fine. So I can plug this into the other equation. Don't plug it in here. You'll get 0 equals 0 and think, oh wow. You got to plug it into the other dude. So the number 2 I can write as 4x minus 3 times negative 2x plus 11 equals negative 3. Cool. And now just solve that like back in chapter 2. So 4x plus 6x minus 33 equals negative 3. 10x, I can add the 33 and I get equals 30.
X equals 3.
Yep, so x equals 3. So y, negative 2 times x, which is 3. Y equals negative 6 plus 11 is 5. How are we doing so far? I mean, so the math involved here is not very intense, right? This is kind of nice. What's the actual answer then?
3, 5.
Beautiful, 3, 5. I like it. So one more method, and then we'll get out of here a little early. So if you're all a little antsy for a break, don't be. We're going to get out early instead. Okay. And I'm spoiling you guys like crazy. That's all right.
Yeah, you
No, we're not spoiled.
That's funny. I didn't expect that reaction. I know, Jeff, you're fine. Let's see. So the next type is called the elimination method. This is the method that I personally prefer when I'm doing this kind of problem. And it's a little more direct. It says, oh, there's too many variables, let's kill one. Right? And again, that's the base of my class, is always violence.
Yeah, of course.
So here's an example. If I had 2x minus y, I guess this should make it work, equals 4. And I have 3x plus y. Now I've forgotten what I did. Oh yeah. Equals 10. So instead of doing substitution, what we actually do, now here's the funny thing. If I add 10 to this side, don't I have to add 10 to this side, of course? Are you all like, well, yeah, Jeff. Well, what is 10 though? Isn't 10 equal to this? So if I add 10 to this, I can add this to this, and I have added the same thing to both sides. That's the key of why this method works. I can add equations directly. Because I am adding 10 to both sides, because 10 is this. So I make a big deal out of something that actually is very simple now. The only reason I'm going to add these two together, and I started with a very easy example, what happens if I add them together? The y's go away. So I'm obviously never going to add two equations together if no letter will die. The whole problem with two variable equations is there's two variables. I want to get rid of one. Substitution kind of is very subtle. Let's just switch one of them. All right. Elimination is more die. So when I add these together, the y's die. I get what here? 5x. Shit.
Oh, this is easy.
I made this one evil.
14.
I didn't mean to make it evil. What did I do wrong?
Just
do 5.
5. Or 9.
Let's make it 9.
11.
Yeah.
Zero.
Is that cool, guys?
Does that
Give me a break. Late in the day, I don't know. This is still bad. Let's make it 1. 11. All right.
No.
So it's 11 plus 4?
3.
15. Oh, that's what I was trying to do. Okay, good. And then divided by 5. X is 3. Now, the one bad part about elimination is you're not going to have an equation that's already solved, but who cares? Where should I plug the 3 in?
In any variable?
I'll plug it in the second one. You can plug it in either one, but the y here is at least positive already, right?
Okay.
You with me? So if I plug it in here, plug a 3 in, so this will be 3 times 3 plus y is 11. So you get 9 plus y is 11, so minus 9, y is 2.
Does elimination only work when there's a negative y and a positive y?
Good. They have to be different signs, but it could be 4x and negative 4x, right? It could be negative 8y and 8y. They have to be the same coefficient, different signs.
Okay, and that will happen often.
So here's a little more advanced problem.
Wait, so the answer on that first one is 3, 2?
Cool. I like it.
We'll check.
All right. Let's see if I can get my brain working. Actually, I'm going to take a major step up here. Let's see if you guys can handle this.
Give us one we'll actually get.
I'll give you one that actually has an answer. That's probably nice of me to do that. Oh, cool. Yeah. All right, let's see how I did.
Yeah, that's so small, like what would we get?
This is gross. You definitely would never want to use substitution on this because none of the variables have a 1 coefficient. They would all have fractions if you solved.
Can I get the practice test?
Sure, come on up. Don't be afraid. You gotta go, you gotta go.
And you're supposed to add those two together?
Not yet. If I add them together right now, will anything cancel?
No.
No. So here's the cool thing. It's exactly the same idea as like denominators. Now, some of you guys are going to be like, that's not cool, Jeff. But it is. Denominators are not that hard. The numbers aren't going to get that ugly. So if you wanted to kill, for example, the x's, what if I had 1/4, 1/3? How do I make those match up? Isn't that the whole idea? I want them to be the same number, different signs. So if I multiply this by what and this by what, I can make them both become what? What would be the LCD here? 12. Do you guys see that?
Yeah.
I can multiply the first one by, and give yourself a little note. Give me a little note too, so I can follow what the hell you're doing. Put a little times 3 for yourself. That's what you're doing, right? So multiply by 3, what do you get? 12x minus 15y equals 21. Good. The most common mistake is people forget that poor little dude on the other side. It shouldn't still be 7. One side, you better do the other side.
When do you know when to do this? When you can't add them, when they don't fit?
What was the whole point? Why did I add these? Because I knew something would cancel. I don't add them if nothing will cancel. I have to adjust them so that something will then cancel. I multiply one of them or both of them. Bless you. If I would have had a 2 here, would I have had to do both of them? If this would have been a 2?
Oh, because you can subtract.
If I would have just doubled this if it was a 2, that's all I would have had to do, right?
I don't know.
We'll do another one.
But then you would have to multiply the 2y by 2.
Well, that's what I mean. The whole equation gets multiplied, of course. You can't just
That
multiply a piece of an equation.
That doesn't fit under that won't subtract the 5y above it.
Who ca- It doesn't matter. You're just trying to get rid of one letter because then you can solve for the other one. You can't get rid of both at once. Not normally, or else you have a weird situation. So what? Remind me, what was it we want to multiply the 2 by? 4.
Oh, wait, wouldn't it? No.
Yeah.
Because it's already negative. They're already different signs.
Minus 12 roots.
And I want them to be different signs, so when I add them, they will cancel.
Oh,
Oh.
Here, weren't the y and the negative y, they're different signs. That's why it was so awesome. Yes, sir.
So if they were the same signs, you could do.
You could multiply one of them by negative. Cool. So make them both the same number with different signs. So I know they'll eliminate, they'll cancel each other.
Just make the x the same number. Just
Or the y, whichever. I could have done the y and then I would have doubled this one
times 2
and
times
multiply
5.
this one by 5, right? Doesn't really matter as long as you get rid of one letter so you can solve for the other one.
Okay.
So what do I get when I multiply this by 4?
Negative 12x plus 8y equals 8. 0. Just
Zero.
kidding. I wrote that down.
So when you add these together, what happens?
You cross cancel x,
These go away.
and then you get negative.
Negative
7.
15 plus 8. Negative 7y. 21 plus 0. 21.
So what I'm saying is you multiply each equation by the opposite.
I multiply this by 3 and this by 4 to make them both 12.
Now, that's people work.
If I wanted to kill the y, I would have multiplied this one by 2 and this one by 5, because that's what that's
They're
what.
not negative 5 or 5?
They're already different signs, so I'm not going to mess with that.
Okay. If they are the same sign, then you would.
Then you have to multiply one of them by a negative, so they're different.
And it
So that
doesn't
they'll
matter
cancel.
which one you multiply by a negative?
Doesn't matter at all.
As long as
There's a lot of flexibility here, but the idea is to get rid of a letter. Divide by negative 7, you get y is negative 3.
Now you plug that back in.
Plug that back in wherever you want to.
How
But do this one. 4x minus 5 times negative 3. Because I know what y is now, right? I can plug that back in. 4x plus 15 equals 7.
Minus 15.
Minus 15. 4x equals negative 8. X equals
2.
negative 2.
Well, I did it on the second equation and I still got negative 2, which is right.
So you plugged in the negative 3 and the 2?
I plugged it in the first one just because. It just doesn't matter which one you plug it into. So let's do one more and then we'll head out after I give you the practice test here. One last one here. So we'll do an example like I just talked about.
What was X on the last one?
Shoot.
He said he'll tell you.
Wait.
Was it,
I got it.
it's negative 2, never mind,
Hey.
or, never mind.
I remember. Alright. So if it says solve by elimination, if I didn't say solve by elimination, could you use substitution on this one nicely?
Yeah.
Because there's an X there that you could solve for very quickly. I'm saying solve, you must use elimination. So of course,
Wait.
do you have to multiply both equations by something, or how can you make something match up?
2 multiplied by 2.
Yeah, so leave one alone, but take 2 and multiply by what?
2. Negative 2.
Negative 2, do you see that?
No.
So you need, what do you wish was here so that it would cancel with that one?
Oh, you need a negative.
So make it a negative 2. Multiply by negative 2. So what do you get when you multiply by negative 2?
Minus 4y.
Minus 4y.
Minus 2x.
Minus 2x. Minus 10. You guys see that? If you want to, it's certainly fine if you want to come up here and put a little negative 2 by things so you don't forget to do them all. Is that cool? That's fine.
The number you multiply is going to vary, depends on how.
Depends on what you need to kill the other piece, yes.
Okay.
In this case, I need a negative 2 because the other guy had a positive 2.
Oh, you're doing it for X.
Yeah, I decided to
Making
kill
is the
X.
same?
Good.
Oh.
If I wanted to kill Y, wouldn't I have to multiply both of them by something? Because 3 and 2 make them both 6. Cool. So now what happens?
Oh,
Negative y.
Negative Y
Equals 7.
equals
Oh.
Negative 3.
negative 3. So Y is
3.
3. Now if I plug it in here, 3 times 3 plus 9. 9. So 9 plus 2x is 7. Subtract the 9. 2x is negative 2. Divided by 2x is negative 1. Those are all steps that should be very simple. Yes?
Once you figure out one equation, once we got y, that's we plug in the other equation.
Exactly. Well, once we get one number, we plug it in either one. Doesn't matter. Those lines are supposed to meet at this point. Either line will give you the other piece of the point because they both agree on that point. Do you get my point?
I do get your point.
I couldn't say it. So what is the answer here? Negative 1, 3. All right, so let me do this practice test, and I'll have the answer key next time.
What was that?
I can do more. Somebody sitting right there, or is that? No, that's me.
Sorry.
All right, guys.
Do you have like a
Let me turn this guy.